Welcome to my channel, DNA.12 Education. Hi students, welcome back again to my channel, DNA.12 Education. Today our topic is differentiation. Level Math for Cambridge International, differentiation by using chain rule, part 3. Okay, students, in mathematics, differentiation can be defined as a derivative function with respect to an independent variable. One of technique to differentiate composite function is chain rule. Mathematics A-level differentiation chain rule part 3. Okay, students, differentiation by using chain rule. So what is chain rule in mathematics? The chain rule provides us a technique for finding the derivative of composite functions with the number of functions that make up the composition determinant. The chain rule provides us a technique for finding the derivative of composite functions with the number of functions that make up the composition determinant. Okay, students, how chain rule works? It works for 1. A more complicated function, a function inside and outside, and a larger as outer function. A larger as outer function. 2. The inside function is evolved by addition, subtraction, trigonometry, natural log, exponent, root, or if function. And number 3, it works for a composite function. Is it clear to everyone? So chain rule works for a more complicated function. The inside function is followed by addition, subtraction, trigonometry, natural log, exponent, root, or if function, and it works for a composite function. Okay, so let's directly go to the next topic, how to use chain rule. Remember this method. dy over dx or y prime, derivative of outside function, leaving inside alone, times derivative of inside function. Okay, how to use chain rule? Just remember this method. dy over dx or y prime, derivative of outside function means you have to leave inside alone, times derivative of inside function. Okay, to make this one clear to you, how to use the chain rule, look at this example. Y equal 3x in 7 to the power of 6. Once again, in parentheses, 3x minus 7 to the power of 6. A very simple equation. Students, y equals 3x minus 7 to the power of 6. We can find several informations. The first is, we call this outside function. So the outside function is parentheses to the power of 6. So, leaving inside alone. And 3x minus 7, we call this inside function. Once again, 3x minus 7 is inside function. Is it clear to you, everyone? Okay, So dy over dx or y prime equals to 6 in parentheses 3x minus 7 to the power 6 minus 1 times 3. Okay, students, I want to explain this one step by step how to find the derivative by using chain rule. Okay, this one. dy over dx or y prime equals 6 times 3x minus 7 to the power 6 minus 1. Do you remember techniques? Yes, this is the technique. Okay. So 6 will be the coefficient. You have to times 3x minus 7 with 6. So that's why we put here 6. And don't forget to reduce the power by minus 1, right? That's 1. So when we have y equal a x to the power of n, so dy over dx equal n times a, right? You have to put down n by multiplication, and then x, don't forget to reduce the power with minus 1. So you have to reduce the power with 1. So that's why we have 6 here, okay, as a coefficient, and the power is minus 1. Is it clear to you, everyone? Okay, now the question, what about 3? Where this number come from? Okay, look at this method. The method is derivative of inside function, right? Derivative of the inside function. Inside function is 3x minus 7, right? So derivative of inside function is 3. Derivative of 3x minus 7 is 3. So that's why we have to multiply dy over dx by 3. Okay, so once again, there are 2 steps that we have to follow to solve this example, to answer this example, how to differentiate this example 3x minus 7 to the power of 6. The first is derivative of outside function, okay, and then times by to the next, we have to times 2 derivative of inside function. Is it clear to you, everyone? Next, so dy over dx or y prime is 18 times 3x minus 7 to the power 5. Okay? 6 times 3, we got 18. And then 3x minus 7 to the power of 5. We got this one, 6 minus 1 is 5. Is it clear, everyone? So when we have y equal to x minus 7 to the power of 6, we got the derivative of the function is 18 in parentheses 3x minus 7 to the power of 5. Okay, students, we go to the next example. How to use chain rule. dy over dx or y prime is derivative of the outside function times derivative of inside function. Okay, that's the method. Please remember this. That's very easy. Okay, now we go to the next example. Y equals to 2x minus 5 underneath square root. Once again, y equals to 2x minus 5 underneath square root. How to differentiate this function? Okay, students, 2x minus 5 underneath square root, or 2x minus 5 to the power of a half. So this function we can simplify to be 2x minus 5 to the power half. A half is outside function, and 2x minus 5 is inside function. Right? Okay, next. dy over dx or y prime is a half times 2x minus 5 to the power of half minus 1 times 2. How you know this is 1 times by 2? Okay, once again, I want to review how we got 2. Students, inside function is 2x minus 5, right? So derivative of inside function is 2, right? This is the function, right? Let u equal 2x minus 5. So u prime equal 2. Very easy, right? So that's why, okay, this equation multiplied by 2. Okay, remember dy over dx of y prime, derivative of outside function times derivative of inside function. This is the formula or the method how to differentiate of the function by using chain rule. Next, now we're going to simplify this function. Cancel, right? And automatically, we find dy over dx or y prime equal to x minus 5 in parentheses to the power minus half. Can we simplify this equation? Of course. dy over dx or y-axis equal 1 over 2x minus 5 to the power half. How do you know that? That's very easy, everyone. Remember, for the exponent, basic exponent, a to the power minus x equals to 1 over a to the power of x. So that's why this one, okay, look at this one. When we put down this power to be denominator, it will be positive, right? Is it clear to you? Y equal to x minus 5 to the power minus a half. We can simplify y equal 1 over, in parentheses, 2x minus 5 to the power half. So the power now, the power becomes positive. Okay, next. So dy over dx or y prime equal 1 over 2x minus 5 underneath square root. Very easy, right? Next, how to use chain rule for natural law. How to use chain rule for natural law. What is natural law? Natural law is logarithm base 2e. Okay, remember this one? this method. Once again, dy over dx equal y accent equal derivative of outside functions times derivative of inside function. For example, of natural law, y equal ln 3x. Okay, the function is y equal ln 3x. Okay. Students, when we have the function y equal ln of fx, so the derivative of y equal ln of fx equals to y prime equals to f prime of x over fx. Once again, y equal ln fx, so the derivative of natural log equals y prime equals to f prime of x over fx. Remember this formula, everyone? Okay? So differentiation of natural log is f prime of x over fx. Okay, students, you're going to answer or to differentiate this function y equal ln 3x. 3x is inside function. Okay, when we have y equal to ln 3x, okay, students, dy over dx or y prime equals 3 over 3x. Three is derivative of inside function. Okay, let u is 3x. So u prime is 3. Okay, by using this formula, okay, f prime x over fx, we found here f prime of x is 3. Okay, over fx is 3x. Right? Okay, and then we can simplify, cancel, right? So automatically, we can simplify this equation. So dy over dx or y prime equal 1 over x. Very easy, right? Next, how do you use chain rule for natural log? I want to give you another example. Okay, remember dy over dx or y prime equals to derivative of outside function times derivative of inside function. Okay, now we go to the next example. Okay, y equals to ln 7x minus 1 underneath square root. Okay. Okay, now we're going to differentiate this function. Okay, remember this one again, y equal ln fx. So the derivative of ln of fx or y prime, yeah, equals to f prime of x over fx. Okay. Okay, students, now we go to the question how to differentiate this function. Okay, students, 7x minus 1 is inside function, but 7x minus 1 we can simplify to be 7x minus 1 to the power of a half, right? Students, y equal ln 7x minus 1 underneath of square roots. We call this root of 7x minus 1 is inside function. Okay, let u is root of 7x minus 1. We can simplify to be u equals to 7x minus 1 to the power half. Okay, now we're going to differentiate this u. U prime equal a half times 7x minus 1 times, to the power a half minus 1. Okay, but don't forget to time by derivative of inside function 1. Okay, derivative of inside function is 7, right? Clear? So u accent or u prime is 7 over 2, right? 7x minus 1 to the power minus a half. We can simplify u prime is 7 over 2, and then we can simplify this one, right? To be 1 over 7x minus 1 to the power a half. So we got that u prime is 7, right, over 2 root of 7x minus 1. That's right. Okay, now we're going to write here u prime equal 7 over 2 7x minus 1 underneath square root. Okay, is it clear to you, everyone? Good. Okay, now we're going to continue to differentiate this ln. Okay. Okay, students, y equal ln of fx. Okay, so y-axis or y prime or dy over dx is f prime of x divided by fx. So when we have y equal ln 7x minus 1 underneath square root, we can find the differentiation or derivative of this function dy over dx equal y-axis 7 over 2 root of 7x minus 1 over root of 7x minus 1. Is it clear, everyone? Just follow this formula, right? Okay, students, go. Next. So dy over dx or y prime equals to 7 over 2 times 7x minus 1. How you know that? Okay, students, dy over dx or y prime is 7 over 2 root of 7x minus 1. Right? This function is this one. Clear to you? And this function, it will be 1 over root of 7x minus 1. Right? Okay, next. Okay, students, root of 7x minus 1 multiplied by root of 7x minus 1, it will be 7x minus 1, right? You can simplify this one. And now root of 7x minus 1 times root of 7x minus 1 equals to 7x minus 1. 7 times 1 is 7. and then to here, left. Now we have the differentiation or derivative of ln root of 7x minus 1 is 7 over 2 in parentheses 7x minus 1. Is it clear to everyone? How to differentiate ln root of 7x minus 1. Okay, next we go to the next topic. How to use chain rule for e to the fx. How to use chain rule for e to the fx. dy over dx or y prime equals to the derivative of outside functions multiplied by derivative of inside function. Okay, students, let y equal e to the 3x. Y equals to e to the 3x. Y equal e to the fx. dy over dx or y prime, okay, y prime equals to e to the fx times f prime x. Once again, when we have y equal e to the fx, so dy over dx or v prime, we got e to the fx times f prime of x. Very easy, right? Okay, students, now we go to the example. Okay, students, y equals e to the 3x. 3x is inside function, right? Okay, so let u is 3x. So u prime is 3. Okay, students, u equal 3x. U prime is 3. Okay, students? Okay. Next. Y equal to e to 3x. So dy over dx of y prime equals to e to the 3x times inside the derivative is 3. Once again, students, how you know this 3? Where does 3 come from? Okay, this 3 comes from the derivative of inside function. This one, right? So that's why y equal e to the fx. Y prime is e to the fx times f prime of x. Let's see everyone. Next, so dy over dx for y prime equals to 3e to the 3x. That's the derivative of y equal e to the 3x. Is it clear to everyone? Next, chain rule with the product rule. Chain rule with the product rule. Let y equal u in x times v in x. Okay, so y equal to ux times vx. So dy over dx equal y prime equals to u prime v plus v prime u. Once again, dy over dx or y prime equals to u prime v plus v prime u. Okay, this is the example of 1. Y equals to 2x minus 7 times 5x minus 1 cubed. Okay, let 2x minus 7, we name this function as u, and 5x minus 1 to the power of 3 is v. Okay? When we have u is to x minus 7, so u prime is 2. And when we have v is 5x minus 1 to the power of 3, we got v prime is 3 times 5x minus 1 to the power 3 minus 1 times 5. Do you remember? Where does 5 come from? Yes, the derivative of inside function, right? Next, so v prime equals 15 times 5x minus 1 squared. Okay, now we go to differentiation. dy over dx equals y prime equals u prime v plus p prime u. Now our job is to insert u, v, u accent, and v accent, or u prime and v prime. Okay, u prime is 2, right? So we put here 2. V is 1, 5x minus 1 cubed, right? V accent is 15 times 5x minus 1 squared. Okay, and u is 2x minus 7, 2x minus 7, right here. Complete, right? Okay, students, we can simplify this equation by distribution. We can distribute the function, okay? Yeah. The distribution is okay, students, we can continue. So dy over dx equals to 2 times 5x minus 1 cubed plus 15 times 5x minus 1 squared times 2x minus 7. Okay, students, our job is to simplify this equation. Okay, to simplify this equation. Listen, students, you can check here. Yeah. For the left side is 5x minus 1 cubed, right? And the right side is 5x minus 1 squared, right? So we can distribute this function by putting 5x minus 1 squared to the outside of the parentheses here. So we can put here the simple one here, 5x minus 1 squared, right? Okay, now we have 5x minus 1 squared. You can simplify. In the parentheses is 2 here. 5x minus 1 only, right? Single one. And then 5x minus 1 squared for the right side is 15 here. And 2x minus 7 here. Left, right here. Is it clear to you how to distribute this equation to make it simple, right? Okay, students, so we can simplify, right? So dy over dx equals 5x minus 1 squared times 40x minus 107. Okay, 10 times 5x is 10x. 2 times minus 1 is minus 2. So 10x minus 2. And this one, 15 times 2x is 30x. And 15 minus 7 is minus 105. So that's why we got 40x minus 107. Is it clear to everyone? So we have the differentiation of y equal to x minus 7 times 5x minus 1 cubed is 5x minus 1 squared times, in parentheses, 40x minus 107. Very clear. Okay, to make it simple, I want to give you another example how to use the chain rule. Okay, so let's go to the next example. Okay, this is the next example how to use chain rule with the product rule. Okay, I have another example here that y equal root up to x minus 9 times 2x minus 1 cubed. Okay, as usual, by using the product rule, let's say this one is u and this one is v, right? Okay, now we got u is root up to x minus 9 and v is 2x minus 1 cubed. Okay, u is root of 2x minus 9. We got u prime is 1 over root of 2x minus 9. Okay, is it clear to you how to find this one? I think it's very clear. Okay, so u prime equals to, remember? Okay. Okay, so I will show you the process how to find this. Okay. Okay, u is 2x minus 9 to the power half, right? So u prime equals to a half times 2x minus 9 power a half minus 1, and then you have to find the inside derivative is 2. Is it clear? Okay, the derivative of inside function is 2. Don't forget. Okay, clear? And then this one is cancel, right? So automatically for the final u prime is 2x minus 9 to the power minus a half, right? You can simplify u prime is 1 over 2x minus 9 to the power a half, or you can simplify 1 over 2x minus 9 to the root. Is it clear, everyone? That's very clear, I think. Okay, go. And then we got v is 2x minus 1 cubed. So v prime equals 3 times 2x minus 1 times 2 minus 1 times 2. I don't know that. How you know that? What does this 2 come from? Once again, 2's come from the derivative of each side, right? Okay, next we got already u, v, u prime, and v prime. Now we go to the differentiation of y. So dy over dx, yeah, dy over dx or y prime equal u prime t plus d prime u. You just insert all the functions to the y prime. So dy over dx is 1 over root of 2x minus 9. Okay, times v, 2x minus 1 cubed. You accent this one right here. Here. 1. And then v. V is this one, right? V. V. Okay, v prime, this one, v prime, this one. Okay. And then u is this one, u. One. Very clear, right? Okay. Okay, so we can continue to simplify this function. Okay, dy over dx equals 2x minus 1 square in parentheses 2x minus 1 over root of 2x minus 9 plus 6 times root of 2x minus 9. So I want to explain how it works. Okay, everyone, I want to show you how this one works. Okay, everyone, 2x minus 1 cubed and 2x minus 1 squared. We can distribute, yeah, all these functions to the simple function, right? So 2x minus 1 cubed and 2x minus 1 squared will be simplified, okay, to be 2x minus 1 squared, right? Or this one. Is it? Do you remember about distribution? Okay, now we have to put 2x minus 1 squared outside of the parentheses, right? Clear this one? This is the parentheses, right? So we can put 2x minus 1 squared outside of the parentheses as the coefficient of all the functions, right? Okay, students, now we're going to simplify this one. Okay, this is positive or a plus here. So we put 2x minus 1 squared outside of the parentheses for the left side. Okay, so it means 2x minus 1 here, and then root of 2x minus 9 still here. Okay, is it clear? Right? And then for the right side, you can check it now, okay, by putting 2x minus 1 outside of the parentheses. Okay, this one. Okay, so 6 and root of 2x minus 1, 6 and root of 2x minus 9 is left inside. Is it clear to everyone? Okay, once again, I want to explain this one. Okay, for the left side, okay, I put 2x minus 1 square out of the parentheses. So, right? So, you can simplify for this term is means 2x minus 1 square times 2x minus 1. 1 here left inside, and 1 over root of 2x minus 9 inside, right? So it will be equal function, right? Okay. Next, for the right side, this one, for the right side, okay, because I put 2x minus 1 square outside of the parentheses here, so yeah, 6 and root of 2x minus 9 is inside in the parentheses, right? Okay, is it clear to you how to distribute this function? Okay, very good. Thank you very much. Okay, next we can continue to simplify dy over dx of this function. So 2x minus 1 square in parentheses 2x minus 1 plus 6 times 2x minus 9 over root of 2x minus 9. Okay, I want to explain this once again, how we got this. Okay, we can simplify this one by using the, what is it, LCM right here. Okay, let's, for the denominator is root of 2x minus 9. Then, so to root of 2x minus 9 divided by root of 2x minus 9 is 1. And then times 2x minus 1, we got here 2x minus 1, right? And then for the second is root of 2x minus 9 divided by, automatically here is 1, right? So it means root of 2x minus 9 divided by 1 is root of 2x minus 9. And then we can times to the top here. Okay, so we got 2x minus 9, right? And don't forget to put 6 here. We still have 6. Okay, so that's why we got this one. Okay, is it clear to everyone? Where does this term come? Okay, that's the concept. I think that's very clear. Now we're going to simplify this dy over dx. So 2x minus 1 squared times, in parentheses, 14x minus 55 over root of 2x minus 9. Okay, I want to show you once again. Here is 2x minus 1. And here is 12x. And here again, minus 54. So that's why we got 14x minus 55. Right? Okay, now everything's done. Okay, so differentiation of y equal root of 2x minus 9 times 2x minus 1 cubed is 2x minus 1 square in parentheses 14x minus 55 over root of 2x minus 9. Okay, that's very easy, right? Okay, students, that's very easy. Okay, students, I think that's very clear about chain rule with the product rule. Okay, students? Okay. Okay, to make sure everything's clear about this material for you, so I want to give you 2 exercises. Okay, students, hopefully everything's clear to you and you can answer this question at the end of this video. Good luck, everyone.